Yeah, cool. So thanks everyone for joining. I'm just going to go over a quick presentation on what MentorColor is before passing it on to Danilo. I mean, like MentorColor is really focused on ensuring the representation of Blacks and people of color in tech. So we're very focused on minority groups, and we want everyone to get access to the experience and the resources that they need to get started in tech and grow their career. Next slide. So we have pulled together some really great mentors from so many different countries. Lots of our mentors also work for different top tech companies, and they're very much there and ready to just help you get started with tech. Next slide. So you can expect to get one-on-one and group mentorship sessions all done online, so through video calls. So it doesn't really matter wherever you are in the world. You can get support on both like leadership, interview preparation, code reviews, and just general career advice. And you can get support all across the entire tech ecosystem, from front end to back end, just like today's session, and like leadership and even product. Next slide, please. And we host these sessions like this one weekly, so you can just join in and learn with others. So feel free to go browse through other sessions that we have upcoming and sign up for those. And yeah, I think that's it. Let's jump right into this session today by Danilo.
Yeah. Let's go. So yeah, hello everyone. My name is Danilo. We are going to talk about backend development, specifically how we are doing nowadays. So before we get started, my name is Danilo. I'm Brazilian. I have 2 cats and a dog. Nowadays, I work for Nordic Entertainment Group as a software engineer, but previously I had a leadership role as solutions engineering team leader at RTB House. If I compare RTB House, which is an advertising company, with Nordic Entertainment Group, which is a entertainment company, which has a streaming service called Viaplay. Both are super different domains, and this is what I like of being a developer. So we are super involved with like several kinds of business, for example, banking, entertainment, I don't know, advertising, and much more. So yeah, that's me. And about the content today, we're going to talk about how like backend development is being handled nowadays. So what kind of skills, activities, and responsibilities we are focusing right now. After that, we are going to decompose a real-world application for us to understand like all the components and how every single one like communicates with each other, and also like what's the benefits of having like these different kind of components. After that, we are going to talk about a bit about like business awareness, because of course every technical decision must be based on business. And after that, we are going to talk about a bit about some tips to make your life easier when it comes to backend interviews and also quick kicking off new projects. Why not? So about like let's start with backend development. But before we go to backend development, it's important for us to know that there are several skills that are needed to like any kind of developer. So here we have, for example, like operational system basics, which means like you need to run commands on your terminal. You need to set up, for example, folders and permissions. You need to set up your own network. You need to set up, not only set up, but create and set up like SSH keys in order to collaborate. When it comes to networking basics, of course, you don't need to be like, I don't know, master on networking, but it's important to understand like how a local network communication is done and is set up. Of course, it's important to know how, for example, domain names are resolved. What's the difference between HTTP and HTTPS? And of course, like its features, like, for example, headers, payload, parameters, and things like this. And if we go forward, it's interesting also talking about networking to know how hosting, like simple hosting companies work. And yeah, like hosting simple applications, it's important. After that, it doesn't matter if you are like Android developer, it's good to have like web development basics, because like HTML, CSS, those are like basically everywhere. So only the HTML syntax and what are the features and the purpose is enough for any kind of developer. It's great to know that. Yeah, super helpful. When it comes to code versioning, it's important to know like basic Git commands, because you need to collaborate with other developers, right? So like manage your own source code. It's helpful for you to not lose your own code. So yeah, super important. And last but not least, testing basics. I know that sometimes like testing sounds a bit like, oh, you need to be senior, or at least, I don't know, a regular developer to put this on practice like properly, but I don't believe so. I believe like since you're like intern or junior, it's important to have like some concepts, like for example, AAA. We're not going to cover this right now, but it's important. If you can like take notes there. AAA is a good concept for you to know. And also, of course, if you have a favorite language, why not know like how to set up at least unit tests by using that language, right? So going back to backend development, it's important to understand what's the difference between backend and front-end developers when it comes to focus. So when we talk about the main focus of a developer, we have on the backend more the business rules focus. What I mean that you need to model what your business require in your servers or in your services. While when you are front-end developer, when it comes to main focus, it's more connected to the user experience, not totally related to like conditions and decisions, but more regarding the user experience on your service or application. When it comes to data focus, of course, the backend developer is going to manage this data. So do simple operations like inserting, updating, and transforming this data. And while the front-end developer is going to handle this data in the data visualization perspective. So enable users to understand this data the best they can. And when it comes to usage focus, the backend side is more connected to availability, while front-end development is more connected to accessibility. So that's, of course, it's super generalistic, but it's a way to differentiate the focus between our kinds of developers. And of course, when I say front-end developer, I'm also talking about like device developers, right? And when we see like the skill set for each kind of developer, we can see that, of course, backend developers have like the need of like databases and also servers and cloud, while front-end developers are more connected to design and style, and sometimes also to devices like iOS and Android. But both kind of developers share this need of the language domain, of course, like programming logic and testing, because all pieces of code needs to be tested, and of course, coding standards. These coding standards are not shared between front-end and back-end, but each like language, platform, or technology has its own coding standards. So it's important to own and understand these standards. So when it comes to like common stacks, so what I mean by stack is a group of technologies that usually it's, I don't know, used alongside. For example, when it comes to Node.js, we heard a lot about like MERN, which stands like MERN, which is like MongoDB, Express.js, React.js, and Node.js. So it's like a group of technologies that usually people use together for starting projects. So yeah, for example, for PHP, we have like LAMP, which stands for Linux, Apache, MySQL, and of course, PHP. These are like the most common, from my experience, the most common main languages. So Python, Node.js, PHP, the .NET ecosystem, and also Java. Those are like the most common stacks, but of course we have other ones like growing, for example, Rust and Go. So I put the ones that I have worked on in my life. But after you choose, let's say you're a beginner on backend developer, after you choose your main language, it's important for you to practice some other concepts with your language. What I mean that you need to understand and practice design patterns. Also, for example, this TDD, which stands for test-driven development approach, for example, or solid concepts. Also, some architectural patterns like microservices, like, how this language, for example, Python, can be used to build like reliable microservices. It's important for you to mix the coding and programming language knowledge with these concepts that are shared for any kind of programming language, right? And when it comes to back-end development, it's not only about programming language. The programming language is just the basic that you need to know. And on top of that, you can add other skills to make, for example, your profile more interesting for companies if you're applying to new opportunities. For example, when you design an application, probably you need to manage and display data. So you need to choose, or perhaps choose many of these databases. For example, here we have like SQL databases like Postgres, like Microsoft SQL Server, like Oracle. We have like some NoSQL databases as well, like MongoDB and Elasticsearch. We have some database as a service platform. So we have here like the AWS option, the Microsoft option, sorry, and the Google Cloud Platform option. About caching, for example, caching is good knowledge you have, because it's also a standard and perhaps a pattern. And we have like Redis, Memcached, and also some managed services for caching. For example, this one is the icon that is used for AWS service. Containers, of course, I put here Docker, which is the I don't know, most famous one, but there are more, and it's important to have this knowledge as well. Like message brokers, when you don't have like synchronous applications, and some automation tools when you need to do when your business requires your app to perform like background processing tasks. And of course, the main cloud providers here, we have like Google, Amazon, and Microsoft. So when it comes to like technologies, it's important to, I don't know, don't feel frustrated, because you can like see all these icons and think like, oh, I will never, I don't know, learn all of this in my life. And that's okay. You don't need to master everything, but it's important to read about it, or I don't know, do some tests like on your local machine, to understand the trade-offs among these services. Example, when it's better for me to use SQL databases over NoSQL databases. Of course, you need to, in this case, you need to understand like if the app or the business requires that the app should be more focused on writing data or reading data. This is a question you should like ask yourself to make the decision. Or for example, the data you are going to manage, is this structured or the structure change over time? So this kind of, I don't know, trade-off analysis is what will help you to choose among some technologies. And sometimes you don't need to master this technology to choose it, of course. Another example, your company perhaps will ask you like, should we use AWS or GCP? I mean, choose Amazon over Google. You can't know that like right away. You need to ask some questions. For example, what are the features my application need? Which one, given I know what my application needs, so which one will be cheaper given like the services I'm going to use? What's easier for my team, given we have already some knowledge on some of them and the learning curve will be like smaller, for example, or less steep. So these kind of things are going to make you like more comfortable. Like you don't need to master everything, but it's important to understand which kind of will help you to find the best answer. Okay, so the next slide, we have here like a trend of languages. If you, let's say you are super beginner and you don't have like a favorite language, in this website, like pypl.github.io, you can find like some charts that shows like the trend for like languages. Of course, this is not like the fully truth. We have like other charts that have different data on this list, but let's say we have like, for example, Python, Java, JavaScript, which is the same as Node.js, for example. We have C#, which is the programming language for .NET, Microsoft.NET. We have PHP. Here we have Go that I mentioned before. So you have like a lot of options, but the idea here is that you're going to like trends come and go. That's the truth. So if you're a beginner, choose something like some language, and of course sharpen your skills on that. But don't stick too much to it, because probably you're going to need to solve a different problem that requires another language. So the idea here is for you to choose, learn, but be open for new opportunities. And of course, the most important thing is the concept or the concepts behind the development. So like algorithm concepts, like object-oriented programming concepts. If you're going to use a functional programming language, also there are like function composition concepts that you need to master, and then you apply on any language that you want to use. So that's the idea. When it comes to database, it's more or less the same idea. So we have here like Oracle, because it's super enterprise focused, but we have also MySQL, which is super common on like internet. We have SQL Server, which is the Microsoft option for enterprise database. And we have like MongoDB, which is the most famous, let's say, NoSQL database. We have Postgres, which is also a SQL and NoSQL database, which is highly used. So yeah, it's important for a backend developer to be comfortable with at least one database system, because it's normal for like web applications to rely on data. Not every time you're going to consume an external API. So you're going to manage your own data. So it's important for you to at least be comfortable with one database systems. I would suggest like MongoDB or Postgres, but it's up to you. And also, before we go and analyze a real case scenario, it's important for us to understand the two ways a application can grow. The first one is the usage of this application. So when your application is going to be used by several users at the same time, for example, your code base and your code will be more focused on enabling more usage, let's say, or more reliability for your application. And the code will be more focused on handling these traffic situations and things like this. While if you have a not that used application, so not that many users at the same time, but you have so many business complexity, so many business rules, it's also a way that your application can grow. And then the challenge here is more regarding like how you can shape your code in terms of like foreseeing like changes, handling exceptions and things like this. So for the first case, I would say a common example for nowadays is like some microservices or some serverless operations with TDD. And for the second case, I would say that we have more like bigger monolith written with DDD, which stands for domain-driven design. So like the domain is like how you model your like real world scenarios into like classes and I don't know, into oriented programming language and object-oriented programming concepts, and also some design patterns like facade, proxy, factory, things like these are more connected to business complexity than to like traffic complexity. So yeah, that's it. So before we get started into breaking down a real world application, do we have questions? Okay, I will assume we don't have questions.
Actually, do you mind if I jump in with a question? There was a specific scenario at my last job where I ended up building an application before I knew about AWS. And I'm curious if that's completely in the past now. Do we build stuff on servers anymore on a virtual private server, or should we be jumping into something like a cloud server before we, I know that you just covered like how to pick which one, but is there ever a use case for a virtual private server anymore for the DIY people like myself?
Yeah, no, I believe there's space or still for this kind of solution, because what drives what you're going to do is like the business need. Sometimes you don't need a like super complex cloud solution for something that is, if it's simple, that's okay, you know. So I believe it's not old-fashioned, let's say. I think it's on purpose, that's okay.
Thank you.
Okay, so like let's take an example probably similar to that question. Oh no, wait, I made a mistake with the order of the slides. So yeah, I will use your question as example, but a bit later. But let's see a real case scenario. Let's say we are going to build or to manage or optimize a online drugstore. So in this online drugstore product, let's say software product, we have three main kinds of users. So we have the employees that need to manage the catalog of items, monitor the sales, and also like use our system to send the items to delivery. We have the customer, which will go to the site to browse items, make purchases, and of course track the deliveries. And we have like some data analysis things that happen. For example, consolidating sales, extracting data, and also generating reports. This application is, let's say, this fictional case, let's say it's running in a super simple, and here is the slide that I was mentioning, super simple architecture. So we have a single point of entry here, which is the domain, so drugstore.com. We have a simple web server here, and also a simple database. Which web server, which language, which platform, which tools, which database, it doesn't matter, right? We are going to talk about concepts that you guys can apply with like any kind of set of technologies. Of course, I'm going to use, I'm using here like some AWS terms, but it's because of the drawer I used, so I'm sorry for that. So in this scenario, we can notice that we have like the one single entry point for everything. We have one single web server, so everything is being handled by the same server, and we have the one single database. So all the data operations are going to happen on the same database, on the same point as well. And there are some like reported problems already on this application. The first problem is that when we have a peak of simultaneous users, our employees can't update the catalog, and also our users complain about like the slow of the pages. We have also some like data analysis jobs that can start on our server, but they never get complete. So we have also some data problems as well. And the worst problem is that users can start the purchase, but they can't complete because they can't pay. And here we have a chart where we have like an average of the CPU of the server throughout the day. So we have like 10 a.m. here, a peak of 100%, almost 100% at 2 p.m. 6 p.m. we have 100% again. So sometimes everything is fine, but sometimes not that much. Okay. Before we go further, I'd like to explain why the payment flow is the worst case. How it works? When the user places an order, like the payment confirmation, so the user inserted already the credit card information, and so the drugstore.com, which is our application, validate the payment data and send a request to the payment gateway for you to process if like the client has conditions to afford this purchase. But this process is not synchronous. Actually, we deliver a request, and we need to wait for them to process. So let's say in a second moment, they are still processing our payment. Of course, it will be successful, but they are still processing. In this meanwhile, our front end or the client browser asks for our application like, hey, the process, what's the payment, what's the status of this process? And of course, we don't have the answer yet, so we are going to answer processing the payment. This is the status. And in a third moment, the payment gateway will make a request to our app to say, hey, the payment is successful. And then our application will restore the payment result and confirm, hey, payment gateway, I received your confirmation, so thank you very much. And finally, our client will ask, hey, what's the payment status now? And we are going to ask to answer, like, the payment is approved. So show the confirmation page for this user, for example. And also, I don't know, everything else, like sending emails, putting the order to be delivered and things like this. But what's the problem? The problem is that sometimes our server is too busy, like the CPU is at 100% of usage and the server is not available. What happens in these kind of situations? So we have like everything in the first and the second step, but when we go to the third step, when it comes to the payment gateway, making a request back to our app, what happens? We are not available. Our server couldn't handle this request. So the transaction is still approved on the payment gateway side, but and also they charged the client already. But the problem is that we don't know that because our application is offline. Not offline, but a bit too busy to understand this request. So what's happening? What's happening is that we are going to have an infinite loop of, hey, server, do you have the payment? But we are going to say, no, we are still processing the payment. But actually, the payment is already done. And we couldn't, unfortunately, handle this payments successfully. Of course, there will be like retries and other like logics to prevent this kind of situation. But if our application happen at least once, right? So going back to our reported problems, we have another one, which is regarding the size of our catalog. So the users are like being affected, like how our catalog, as our catalog is like growing, the queries duration on our database are like increasing. The duration time is increasing dramatically, and it's affecting many things. For example, our employees are suffering when managing the catalog. So and also if we sum this problem with the previous problem, we are going to have like a much higher severity problem. So what's the solution, let's say? Before we go to the solution, there are more risks that are not reported, but we can notice. The first one is the lack of redundancy. So if the web server is not there, let's say not available, it's difficult to replace it because it's everything server. And also the database is the same. Like if the database goes down, we don't have something to replace it. And also we have like too many responsibilities for the same web server, and of course for the same database. So how can we approach to solve all these problems in a more modern fashion, let's say? The first idea is to keep calm and solve the problems like in a isolated way, let's say. So analyze the symptom, and then we are going to handle. And it's important to avoid doing many changes at once, because then you're going to have like too many moving pieces. So the idea is like to plan, analyze like what's happening and what's the problems the users are facing. And then we do some things to solve this isolated situation. We assess if everything is going well, and then we are going to adjust to keep improving and perhaps solving another problem and so on. So yeah. Don't try to solve everything at once. It's, of course, sounds obvious, but when we are beginners, we tend to try to solve all that we know, and yeah, it becomes messy. So yeah, that's the advice. Coming back to the reported problem number one, what we are going to do, we are going to tackle the web server availability. So to achieve this goal of availability, we are going to tackle two main concepts, let's say. The first one is the concern separation. So we are going to use this correct technologies and the correct resources for what they are best on. And of course, we are going to handle data currency later on. So the first thing is that when it comes to concern separation, we are going to isolate the business rules. So when we have a web server, it's common for us to have, for example, static images and CSS files on all like icons, HTTPS, certificate handshakes and things like this. Everything handled by the same application, by the same server, which is this guy. What we are going to do, we are going to split responsibility on other resources. So the first thing we're going to do is to create another point of contact. In this case, I'm proposing that we are going to have a AWS S3 bucket to handle all the static assets, which are images, CSS, JS scripts, and also HTML files. And then our web server will handle only API requests and data processing jobs. And in front of this pair of components, we are going to use AWS CloudFront. We will act as a proxy to understand, like, let's imagine we are receiving image request. So CloudFront will decide who needs to handle this request. And then the rule will be like, okay, S3, and then the connection will be made like this. But then we are going to see like /API / I don't know, users / something. And then CloudFront will handle like, okay, this is a API call. So I'm going to point this request to this component, and this will be its main purpose. So that's it. Of course, given CloudFront is a CDN service, it can also cache these static files, and why not some API requests, but let's skip it. The second thing, and we are going to grow a bit our architecture, is to separate some background processing from the main web server. So the purpose of our web server is to process payments and user requests and things like this. So we are going to leave it only processing these API requests, and then we add a new component here, which I'm suggesting here, AWS Batch, which is a service for batch processing, but it could be like another server. It doesn't matter actually, but another component that will run all the data processing tasks, like the background ones. So the responsibility when the user is coming to, I don't know, like for example, make payments, our web server will be free. For example, in case of some background processing, if some background processes are still on, I don't know, in progress, we need to make our server available, even though we're handling other requests and other stuff like background processing. Okay. When it comes to data concurrency, the idea is to protect our data sources or our production data sources for what it's the main purpose of it. So in this case, we have a database that is handling not only the client requests, but also some background processing and also some like reports and things like this. So what happens? Many components are like competing for the same resource. We are going to face it. How? So the first thing, we are going to avoid going to the database for some expensive but avoidable operations. So let's say we don't have like catalog changes for several days. So why going to a SQL database to get all the catalog if we can, for example, cache this data on memory and put, for example, a time to live of 7 days. So this data will be cached much more. It will be much faster to access this data, and it will cost much less for us. Not in terms of money, probably also in terms of money, but in terms of performance for our web server. So it will make our web server, of course, more available, but also it will decrease the load on our database. So this is the first thing. To exemplify how a caching logic works, we have here like a fake script, which is like we have like this DB object, which is like our DB handler, and also the cache, which is our cache handler. And we have this operation like get similar products. Let's say this operation is super expensive, like it takes more than 10 seconds to perform this action, this query on the database. So how we avoid this? We can create, we can create a key for our request. We can use, before we perform the operation, we can check on our cache if this key is available there. If so, we are going to return these products, for example, these similar products from the cache, and this will like be avoiding the super expensive query. But if not, that's okay. It will happen, right? Because sometimes we don't have it. So what we are going to do, we're going to perform this action. So we're going to go to our DB and use this method here, like get similar products with our product ID. And then we'll have on our server memory the similar products. So at that time, we're going to cache this information. So set this data to the cache and then return this same data to the piece of code which is requesting it. What's the beauty here? The beauty is that after this process is there, let's say the next user requests the same data. Well, what will happen is that this cache key will be the same. And at this time, the return of this cache.get will not be empty or will not be null. And then we are going to avoid the rest of the code. So it's a kind of blocker, protector, but of course we are going to answer the correct data. So yeah, this is a super simple, but good example of how you can cache things. And by using our code, of course. Okay. And the next thing, but before we go to the next thing, it's important to understand what is suitable for caching. For example, if we for our employees, they need to manage the catalog. We know that they need to perform this action with the latest version of the catalog. So this operation is not suitable for caching, but they need to monitor sales. Sales are going to happen often, but they don't need to see the sales like super live, let's say. So this is an operation that can be cached, and also the deliveries, perhaps it can be cached. When it comes to like consolidating sales, it can't be cached because when you consolidate something, you need the latest status. When you extract data, the same, because you need the latest state of this data. But when you generate reports, you can operate with like cached data. And when it comes to the customer, when the customer browse items, we can cache these items because the catalog doesn't change that much. But when the customer makes purchases, it's important to have the freshest data that we can, so we can't cache this process. But to track deliveries, perhaps we can cache the information. For example, let's say the same user is refreshing the page so many times. We don't need to go to the database to see if we had a new update because, you know, deliveries, it will take days. So it's okay to show cached data for this user. So yeah, that's it. Just be cautious, right? And when it comes to like protecting your data source, I would say that these batch operations doesn't need to, place competition with the actual requests that our users are going to perform on our web server. So we don't need to perform these batch operations on the same database that is running our application. So what I would suggest is to create a replica or replicate this data somehow. I'm not sure what's the best way, but split the data. For example, this one is always the data regarding yesterday, and every day you back up this data to this server. So you have always like D-1 data, and the batch of operations perhaps they can be performed on this like not super up-to-date data, and it will be enough for my business. Perhaps it's something that you need to assess, but it's an opportunity for us to once again decrease the load into this database. And yeah, that's it. And about that other bonus risks that we saw previously, of course, we now delegated different like component responsibilities, but we still lack redundancy. So if my server fails, in this case, for example, if my web server fails, it doesn't matter if we have like a robust database system with replicas and things like this, because our users will be affected. So the idea here is to put a load balancer like before our application, and then we have several instances of our application. So if one unfortunately die or is too busy, the other ones can handle the traffic, and the load balancer will be the one to assess like which is the best server to redirect the requests that are coming from our users here. Of course, all of these servers will access the same cache and the same database, and the replica here is untouched because the case is that we have several instances here. So, of course, we can reduce this or enhance the fault tolerance also for our database. There are several strategies, but the case here is to show that the idea is to multiply the resources and then route somehow the consumers to use this shared resources. So it will increase considerably your redundancy and of course availability. So yeah, that's it. And now we have space for questions. If you guys have something, I can see the chat here. Any refers to material that are useful as an introduction to calculated. Yeah. I don't have I don't have a material regarding like how to calculate server load or things like this, but I can send you guys later actually. When it comes to cloud server pricing, I would say a good tool is the calculator. For example, if we type on Google like AWS calculator, you can like you have like a tool that you can like put, for example, put resources here, and then you say like how much you're going to use and so, and then you and then you add, and you have like some kind of estimated cost. Of course, it's approximate, and you need to have your architecture like this to be able to assess the price. But yeah, it's a tool. Azure has a similar one, a good one as well. So yeah, I would say so. But okay, moving forward, we have the business awareness, because we are talking so much about like technical decisions, of course, generic ones, but technical decisions. But it's important for us to stick our technical decisions regarding some pillars. What are these pillars? Like, you need to be aware of what are the company goals for you to, when you need to, for example, to choose among a cloud provider, you know, like, okay, my company wants to increase, for example, availability the most we can, or we need to save money and decrease costs, for example. It's important for you to know this before taking technical decisions. And it's the same for the product and also for your team. This kind of environmental information is super important for you to take these decisions. But I'd like to go further with your own goals, because if you want to use a certain technology, a new language, implement new, unit or integration tests that your company doesn't do right now, and no one is against it. Like, your company would allow it. It will not like harm your deadlines. So take the opportunity, go for it, do it, because your goals also matter when you take technical decisions. If it's up to you to choose something that will benefit yourself, do it. And of course, you're going to do it like with moderation. So do it. It's important for you. It will not like harm the company. So go for it. I think that's the idea. Wait, perhaps I skipped a question. The question is, how should one reason about the architecture you proposed when you have something like React app with server-side rendering? Yeah, that's a good question. Actually, when we have like SSR, which stands for server-side rendering, we have like a part of our code running on the backend and another part of the code running on the front end. I would say it's the same as a backend application, but yeah, perhaps I'm wrong. But I would say, coming back a bit, I would say it's more or less the same as a backend application. But of course, we can create like tactics or strategies to render these pages that are being rendered on the backend side. And put them into, for example, the same bucket as all other static pages. So we're going to implement a kind of fallback, right? So the request is coming here. We know that we have like server-side rendering. We're going to try to find it here. Of course, CloudFront is not suitable. We're going to have like a middleman here, perhaps a standard that we have. Not a standard, but it's a approach, super common nowadays. It stands for backend for frontend. It's okay, it's a pattern. So what is this like backend for frontend? Is a backend application super focused on the front-end needs. So in this case, we could have like a backend for front-end service here to implement this logic, like, hey, I have a request incoming here, an incoming request here, and then we need to understand, like, is this request already perhaps rendered on my server, and then I can perhaps serve to the client like easily. If yes, then we are going to get this data from the static bucket, let's say. But if not, we can process it here, for example, put the resource here in the bucket and then return and be more prepared for the next one. Of course, sometimes it's not possible. It depends on your application needs. But yeah, I mean, yeah, good question. Super challenging. I like it. I don't have the answer. Perhaps I don't know. Perhaps I shown some ideas, but yeah, I don't have the answer. Very, very nice question. Okay, and finally, some like additional tips. Actually, I'd like to exercise one concept here, which is the concept of production ready. You guys probably have faced, if not, you will face, for example, a code assignment for an interview or for a position that you are looking after. And then they will ask you, like, create a code, like, and do whatever you think is suitable to make it production ready. What does production ready means? What does production ready mean? In my opinion, also it's totally personal. Probably there are people that will perhaps disagree with me. But the first thing is that to be production ready, a piece of code needs to implement all the features needed. So you understood the business, you understood the requirements, and you implemented the features. This is the basic. So what my app needs to do? It needs to do something, and it does. So that's the first step. The second step is testing, because testing is super helpful when we have like code changes. Also super helpful when we have like many different people working on the same code, and then you do a change and you need to assess quickly and automate in an automated way if your change introduces or not a bug for the existing code base. So testing is super important, and it is super required for a production ready code. So yes, you need to deliver some tests to your features to make it production ready. The third step, I would say, it's the documentation. So if you have a code assignment and you don't have at least a README on the root folder, probably you're not doing that right. Of course, the code can be amazing, but it's important for other developers to understand how your code works and make it easier for them to understand like what were your decisions and why, and and what does your code depend on, and things like this. So a good documentation, and don't be afraid. Like sometimes developers are afraid of like writing like text, let's say code. No, we are very good on code, but when it comes to text, we are a bit afraid to write, and then the documentation is not like, oh, super nice. But the case is that it's better to have something always. So if you're going to deliver a code assignment that is meant to be production ready, don't miss the documentation part. It's super important. And the last part, and the trickiest one, is the observability one. Because let's say your code went to production and users start to complain about the features. How can you assess or understand what's happening? So it's important for you to be able to debug your own code, but on production environment. So of course, you're not going to debug your code like line by line, but you have like monitoring and observability tools to allow you to understand what's happening in that environment. For example, at least you need to have a good logging throughout your entire system to handle these like exceptions. But of course, you can have more when it comes to observability, for example. And let's imagine you have like several different like resources that exchange messages. It's important to have a tool to track these messages, at least for a short period, like 7 days, for you to be able to track everything and see what's happening on production. Because after you release it, you don't have the control of the code anymore. So it's important for you to be able to monitor and to assess problems. And yeah, that's it. That's all actually for me today. So if you guys have questions, now it's the time. I'm monitoring the chat. So if you're writing, go on. I will.
Oh, someone has their hand up. Excel,
oh, sure.
Can you go ahead?
Oh, yeah, thank you. Yeah, so thank you so much for your presentation. It was really interesting and yeah, exciting as well. I just would like to say, how would you suggest that someone who, just using myself as a reference, I have a bit of experience with a number of the tools you mentioned, but I haven't really worked with production code before. So like, how would you suggest that someone with little experience, while in, like I'm still in university, like how do you suggest that someone would get hands-on experience, say while in school, apart from internships, which are like the most obvious ones, because there's only so much that the school is going to teach you, right? A lot of what you mentioned are not really taught in school. So how do you suggest one goes about like the whole process of learning, and most importantly, like developing a good foundation? Because I think one of the things that I've struggled with is, trying to just learn things here and there just to say, oh, I know how to use this tool, I know how to use this tool, but in the end, you don't really know how to synthesize everything, just like how you are doing. Because I really like the part where you were giving suggestions of, what kind of architecture to use in a given scenario. But that's like synthesis, right? And that's not really something you learn in school. So yeah, how would you suggest one goes about the learning process and developing a solid foundation?
Yeah. Oh, thank you for your question. Actually, it's super tricky. I faced the same situation. What I did, I mean, I don't have the answer for this question. I will share like what happened to me and how I tried to like, I don't know, to succeed on this case. It was like, yeah, I could like write code. I could like put some things in production for like some freelances on things like this. I had like some like college projects that I was like involved, but I didn't feel I was ready at the time. I would say I don't feel still, but let's say at the time I didn't. And the case is that I had a project, like it was only mine, and I wrote that project. It was like a calendar scheduling thing with some like email notifications. That was that. At first, I wrote that using VB, Visual Basic 6. So it is super old. I mean, I'm perhaps disclosing my age here, but yeah. And then what I did over time, it took like years, but the process is what's important. I wrote that application by myself using my free time with all the skills that I had at that time. And it was just VB6. And then after I learned, for example, C#, I said, okay, let's do it with C#. And then I faced some different challenges by doing the same task. So I was pretty sure that about what I wanted to accomplish, but the new language created challenges for me. And these challenges helped me to understand better the language. And then I said, okay, so now I want to store these calendar things on the database. So which database? I chose one. It was SQL Server from Microsoft at the time. And then it introduced for me another level or another layer of complexity. And then I like rewrote this same application over and over again. The last example is that I'm going to do that right now, not right now, but perhaps in a few weeks, because I'm trying to learn Go, the language from Google, Golang. And I want to practice. So I'm going to write a similar application and I will exercise that by doing that. So yeah, before I do that for production, I will create an application by myself and I will take my time, on my free time, and it will be like this. And I would like to suggest for you to challenge yourself also. For example, if you are super good with Java and MySQL, nice. Try to make your code fully asynchronous. Try to put your code on a like free tier on AWS, for example. It will cost you nothing, but you challenge you a lot to put it there. And then you say, okay, I put it there. And then, I don't know, talking to friends, you see that, I don't know, the trend is to develop a serverless application. So get this simple application that you put on Amazon now and make it serverless, you know? So this will be like baby steps. It will feel like baby steps, but actually you're going to be building a solid foundation for you to face confidently your daily activities on a like proper or actual company. That's how I face it. I'm not sure if it's the best approach, but it's how I do that.
Yeah, thank you so much. That was really insightful. I wrote down some notes and I've actually been practicing some of the things you said, so I'll just like keep it up still. So thank you so much.
Yeah, no, I thank you. There are some things on the chat as well. Nice you guys shared your approach on the chat. Nice, very nice.
Yeah, I have one, Danilo. Just one quick one. It was great when you spoke about observability and kind of like instrumentation. And I know that this is something that is not always the first thing that people think about when building the application. And I kind of wonder, like, what are some of the ways that, like, some of the tools that you can recommend for people to use when trying to plug in observability into the backend system, for example.
Yeah, that's that's a good question, because like the best tools we have, they are super proprietary right now, at least the ones I know. So I'm talking about like SignalFX from Splunk, and also like, for example, AWS X-Ray, when it comes like to tracking, like monitoring how pieces of your application like communicate. There are like some other ones with like free tier as well. For example, I'll type I'll type these names on the chat. So we have like AWS X-Ray, we have Splunk observability, but we have already like some lightweight ones, and also like helpful for front end or full stack applications like Sentry.io. Let me think about it. Yeah, I mean, that's more or less it. I'm not sure if I fully answered your question, but I'd like to go a bit further to say, like, sometimes we don't feel the need of having something like this until we are facing some challenges. So what I advise you guys to study as well and to practice, there are some tools, like for example K6.io, that are focused on load tests. Why I'm mentioning load testing? Because when your application is under stress, probably you face some situations that on your local machine you can't simulate and you can't reproduce. And these will be situations that sometimes you have problems that you can't track, and you need something to monitor your application during the load tests. So yes, try to like challenge not only yourself with your skills, but also your application in terms of, like, for example, usage. So K6 is super lightweight, it's simple to use, and has a free tier as well. So yeah, good to study.
Thanks. Yeah, so I guess we've come to kind of like the end of the session, since there are no questions. So thanks a lot, Danilo, for this wonderful session. This was really great. I'm sure everyone enjoyed this. And yeah, for those of you that that need to get additional advice, like maybe on a one-on-one setting, feel free to go and book Danilo or any other mentors on mentorcolor.org. And yeah, thanks a lot. And give reviews also. You should receive an email right after this. So let us know how you benefited from this session and kind of spread the word.
Thank you so much, guys. Thank you for the opportunity as well. I'm super happy.
Thank you so much.
Thank you so much. It was really nice.
And maybe I want to add something. Danilo will hold another session in a few weeks. So if you're interested in joining that one.
Yeah, that's true. We're going to talk about like Agile and a bit of Scrum. So yeah.
Looking forward to that one too. Great.